Okay, having covered some of the basic grounds about what is ecology and the ecological interactions that we're interested in and so forth, let's start to talk specifically about forests and forest ecology. And I want to do this by taking a little tour in strictly in California in a series of ecosystems that I think say a lot about Western North America, the biological, ecological, and management issues here. Now, our forests in the West tend to have at least two things in common, and that's that there are lots of extremes in temperature and extremes in moisture. And the way that our forests behave in time and space oftentimes reflects these really substantial environmental stresses. The way our plants look is a direct reaction to these environmental dynamics. Now, I use the word adaptation for our plants, and what I'm talking about here are physiological, physical, morphological traits of plants that maximize their fitness, their capacity to reproduce, and for their offspring to reproduce as well. This is the kind of evolutionary dynamic and evolutionary fitness that perpetuates populations and perpetuates information. Put in a very kind of maybe dangerously plain terms, I'm talking about the way plants look. The way they look, and furthermore, I want to emphasize that the way they look is not by chance, or it's not solely by chance. The characteristics of plants are oftentimes an adaptation to the stresses of their environment, whether that's something defensive like these thorns and these plants here photographed in Oaxaca, Mexico, or their adaptations to low moisture and high temperatures. Okay, we only left California for a short period of time. Let's go back to California. Let's go to the Mojave. This is some of the hottest and driest parts of California. High temperatures and low moisture limit the vegetation in these ecosystems, greatly limits the productivity. These are relatively low productive ecosystems. They do have a lot of woody plants, but we wouldn't necessarily call it a forest because it lacks sort of the multi-layered, the multi-strata characteristics of forests, and it's not as clearly dominated by woody plants. And one of the reasons that I feel very comfortable, I think it's very natural to talk about a place like the Mojave Desert, a distinctly non-forest environment, in the context of forest ecology is because you only need a little bit more elevation and a little bit more precipitation, and you transition out of that ecosystem type and into forests. This is the Providence Range, which is in the Mojave National Preserve in California. And what happens here, in just over the course of about 1,000 meters, you transition out of this desert scrub vegetation and into a pinyon pine forest that dominates the top of the mountain range. What happens here, and this happens with all mountain ranges, the physical object of the mountain forces air masses up into the atmosphere. The upper atmosphere is cooler, and that causes moisture in those air masses to condense and fall out of it. So as you go up mountains, the ecosystem becomes wetter and it becomes cooler. And as you increase both of those factors, as you increase precipitation and decrease temperature, you are more likely to transition into an ecosystem that is dominant forest. And this is just moving up that mountain range and turning back and looking downslope, and you can just see that the lowlands are all dominated by that desert scrub here. Hot, dry environments. They're just too hot and too dry to support forests. Now, as we get up into the high country of California, things change again. The high elevation forests of California are dominated by whitebark pine, limber pine, and even in some areas, bristlecone pine. These are trees that are adapted to very cold temperatures, very low temperatures, and however and dry summers. These trees tend to get most of their moisture from melted snowpack. So they have periods of the year where there's plenty of water, and then other periods of the year where they are very water limited. But it's still warm enough and moist enough in the higher elevation of the Sierra Nevada such that the dominant vegetation still is forest. Contrast those forests with the high elevation plains and grasslands of the Eastern Sierra, and you've got an ecosystem that is still quite cold, sometimes has relatively high water content of the soils, but is not necessarily dominated by forests. So as soon as one moves from the high elevations of the Sierra Nevada and down into the lower areas, you got this kind of situation where it still can be quite cold in the winter, but it's not wet enough, and it's not wet enough at the right time of year for forests to dominate. So I don't want you to have the misconception that it's only a matter of precipitation. The timing of precipitation matters also for the dominance of grasses versus shrubs or trees. Water is a constant problem for forests, for trees and forests, and there are two more examples I want to show that illustrate this. First is too much water. Plants, trees and plants, trees are plants, and in both cases, if you're going to live in a really wet environment, you need to be adapted to that. In swamps, one of the limitations for forest trees is that they can't get oxygen to the roots. That can actually interfere with water uptake in some cases. And many ecosystems are adapted to this either by structures of the roots that help get oxygen down into the roots, or by simply having high tolerance to low moisture conditions. Once again, back to the Eastern Sierra. This is the Manzanar site in near Lone Pine, California. And this illustrates another problem that this is especially common in the West, and that's that it's real kind of flood or drought. Lots of water comes off the Eastern Sierra that floods the lowlands, and along channels we still have, can oftentimes have dominant forest. Those tend to be riparian forests. They are trees that are adapted to high water content. They're adapted to dealing with occasional floods. They're adapted to maybe have very deep root systems to acquire moisture from deep within the soils. But they also have to have some capacity for dealing with the periods of time when moisture availability is very low.